Imagine for a moment, you're sitting in an electric car, maybe charging your phone, or perhaps just benefiting from clean energy, like from a wind farm. What if I told you that behind all that, there's this crucial, often invisible material working away silently, making sure everything just works? It's kind of the unsung hero, really, woven into so much of our modern lives.
Okay.
Okay, let's pull back the curtain on this a bit. Today, we're doing a deep dive into something called the Global Impregnating Resins Market. Now, I know the name sounds pretty technical, right? But honestly, these resins are incredibly fundamental. They aren't just some obscure thing. They're really the backbone for efficiency, for reliability, and so much tech we use constantly.
That's exactly right.
Yeah.
To put it simply, impregnating resins are highly specialized materials. Their main job is to enhance electrical insulation and also boost structural integrity. You could maybe think of them as a kind of high-tech liquid armor.
Hmm.
Once it's applied and cured, it gives protection, strength,
Mm-hmm.
and their uses, they're across really vital sectors. Safeguarding electronics, making cars more advanced, strengthening renewable energy structures like wind turbines,
Right.
and keeping heavy industrial machines running well.
And our mission here in this deep dive is to really get a handle on the significance of this material. We want to uncover the surprising global growth behind it, figure out where it's making the biggest splash, and explore why it's become so vital for, these next generation applications. It's way beyond just a niche product. It's a global enabler.
Absolutely. And just to give you a sense of scale, this market was already valued at $1.73 billion back in 2021. And it's not just staying there. It's picking up speed. Projections show it reaching $2.20 billion by 2025,
Okay.
and then climbing pretty significantly to about $3.57 billion by 2033.
Wow.
Yeah, that works out to a consistent compound annual growth rate, the CAGR, of 6.22%. That steady climb, it tells you something. It signals this fundamental increasing demand for what these resins offer. Reliability, performance.
Here's where it gets really interesting for me. Because those billions, they aren't just abstract numbers on a spreadsheet. They directly connect to the technology you use, the things you rely on. Let's maybe step away from the market value for just a second and think about what these applications actually mean in your daily life. Where's the surprising place these might be working away that we don't even realize?
Well, a good place to start is electrical insulation. That's probably their most basic foundational role. Think about your phone, your laptop, even the power grid infrastructure outside.
Okay.
These resins are absolutely critical in preventing electrical failures. They act like a protective barrier, shielding delicate circuits from moisture, dust, heat, vibrations, you name it. Without them, we'd see way more short circuits, more breakdowns. The lifespan of our electronics, our power systems, it would take a massive hit. It's basically this invisible shield keeping the electricity flowing smoothly and reliably. Then you've got the automotive sector, which is, it's going through a massive transformation right now.
Definitely. EVs everywhere.
Exactly.
Yeah.
With electric vehicles, EVs, the electrical systems inside are just incredibly complex now. So impregnating resins are becoming absolutely crucial. You find them in the motors, the inverters, even some battery parts. They help make these components lighter, more compact, and importantly, more efficient.
Right.
And that translates directly into things you care about, like longer battery range,
Yeah.
better performance for your EV. So it's not just about protection, it's about actually optimizing the whole system.
That's incredible to think about. Seriously, the next time I see an EV charging, I'll be picturing this invisible resin shield, making sure everything's okay under the hood. And you mentioned clean energy. What about wind power? Those huge turbines must take a beating.
They absolutely do. Wind turbine blades are a perfect example. They're enormous, constantly under immense stress. Wind, rain, temperature swings.
Yeah.
They need to be incredibly strong, but also light for efficiency. It's a tough balance. Impregnating resins are vital here. They strengthen the composite materials used in the blades, making sure they can handle years, decades even, of relentless operation in some really harsh environments. They're literally building resilience right into our renewable energy future. And finally, industrial machinery, the heavy-duty equipment in factories, building stuff, the advanced robotics.
Right, the automation.
Yeah. These resins are key there, too. For durability, for peak performance, they protect parts from wear and tear, from the heat of constant use, from corrosive chemicals, maybe. Basically keeping production lines running smoothly, reducing that expensive downtime.
So yeah, it's crystal clear these aren't just some, obscure chemicals. They are foundational elements. They don't just support innovation. They actively enable the efficiency, the reliability, the performance of technology shaping our future. They're really embedded in progress itself.
Okay, so we've covered the what and the why. Let's swing back to the market's growth. Those impressive numbers. Because that consistent trajectory, it really highlights how widespread the commitment is to these materials globally. So what does this steady 6.22% CAGR expansion really tell us about the global economy overall?
That's 6.22% CAGR sustained from 2021 through 2033. It's very telling. Like you said, it's not just a short-term bump. It reflects a deep structural demand. This growth isn't just about making more things. It signals a fundamental shift. A shift towards more sophisticated tech, more
Mhm.
electrification, higher performance needs across, well, almost every industry.
It's almost like the global economy is subtly upgrading its entire nervous system, you could say. And these resins, they're providing that crucial insulation, that reinforcement. But, and this is important, this growth isn't the same everywhere. It really varies quite a bit by region, reflecting different development stages, different industrial focuses, how quickly new tech is being adopted.
That's a really key point. It's not monolithic. Okay, so if it's varied, let's take that virtual tour. Let's explore where this growth is hottest and maybe dig into why. Where are we seeing the most dynamic expansion?
Right. We absolutely have to start with the powerhouse, Asia Pacific. This region isn't just growing, it's dominating, projected to expand from around $621 million in 2021
Okay.
to a pretty staggering $1.35 billion by 2033. That's a strong 6.87% CAGR. And within APAC, China's really leading the charge. Expected to hit $538 million by 2033, with fastest regional growth, 7.41% CAGR. India's right behind, projected at $251.5 million, also with very strong growth, 7.38% CAGR. But it's not just China and India. Japan's a major contributor. South Korea is growing steadily. And what's really interesting is how broad this demand is. You see strong growth across Southeast Asia, Taiwan, Singapore, all showing solid demand, suggesting this region-wide tech surge. Even the rest of APAC categories growing fast.
Those APAC numbers are just, they're huge. It really paints a picture, doesn't it? A mix of massive industrialization, fast urbanization, and just an accelerating adoption of advanced tech across so many countries. Is it fair to say they're kind of building this reliance on these advanced materials right into their development, maybe more so than older economies did historically?
I think that's a very astute observation.
Yeah.
In many ways, yes. You see these economies often leapfrogging older tech. They're integrating materials like impregnating resins into new manufacturing, new infrastructure right from the start, especially in things like EV production and renewable energy projects, which they're building out at a massive scale. Okay, now let's look at the more established markets. North America, for example.
Mhm.
Its revenues were about $510 million in 2021, expected to grow to nearly $995 million by 2033. That's a solid 5.84% TAGR. The U.S. obviously has the lion's share, projected around $764 million.
But interestingly, Canada and Mexico are actually growing a bit faster. Canada at 6.23% CAGR, Mexico at 5.98%, which suggests that while the U.S. market is mature, its neighbors might be seeing, I don't know, a boost in domestic manufacturing or maybe strategic investments in certain high-tech areas, perhaps linked to trade deals or something. Then across the Atlantic, Europe, also a very significant player. Sales were around $359 million in 2021, projected to rise to about $708 million by 2033. That's a 6.02% AGR. Germany, being the manufacturing heartland it is, leads there. Projected $138 million by 2033, growing strong at 6.43%. The UK follows, around $74 million. Then you see pretty stable, consistent growth in places like France, Italy, Sweden, hovering between 5% and 6% CAGR. And interestingly, the rest of Europe category is actually surging ahead at nearly 6.9% CAGR, which points to diverse pockets of innovation, maybe infrastructure upgrades happening across the board.
It is fascinating how North America and Europe represent that mature industrial demand. Their growth isn't just about building brand new factories. Maybe it's more about refining what's already there. I imagine a lot of this is driven by, well, ongoing innovation, upgrades to older infrastructure maybe, and definitely the push towards green energy, more automation. Does that sound right?
Absolutely, that's spot on. In these developed regions, the demand for these resins often comes from needing to boost efficiency, meet tougher safety standards, extend the life of existing systems. Alongside, of course, the big transitions to sustainable tech and advanced manufacturing, it's less about building the foundations and more about continuous optimization, integrating those cutting-edge applications. Okay, let's quickly touch on the emerging opportunities elsewhere. Starting with South America, this market's growing steadily, from about $95 million in 2021 to $236 million by 2033. That's a respectable 6.42% CAGR. Brazil leads the way there, projected at nearly $79 million. And Colombia actually shows a particularly strong growth profile, around 6.6% CEGR, supported by others like Argentina, Peru. Moving to the Middle East, here we see more moderate growth, reaching about $150 million by 2033, up from $81 million in 2021. That's up 4.73% AGR. Saudi Arabia is the biggest piece there, $61.7 million. Turkey follows. Countries like the UAE, Egypt, showing slightly stronger growth, probably tied to infrastructure projects, diversifying their economies.
Makes sense.
And finally, Africa. The market's expanding from roughly $68 million in 2021 to $136 million by 2033. That's a 5.21% CAGR. South Africa leads that growth, about $57 million, with Nigeria following around $34 million. Here, the demand is often linked to foundational infrastructure, building out manufacturing, increasing access to electricity.
That's such a compelling snapshot. Really diverse economic landscapes driving things in different ways. In these emerging regions, it feels like the demand is directly tied to the groundwork, doesn't it? Scaling up manufacturing, getting plugged into global supply chains. A different kind of growth engine than the mature markets, but clearly just as vital.
Exactly. And if we sort of connect all these dots, zoom out to the bigger picture, what these regional trends really show is a global, almost universal thing happening. It reflects how pervasive industrialization is, the relentless march of technology, the constant need for investment in the infrastructure that just underpins everything, from the established giants to the rapidly developing economies. That need for robust, reliable, high-performance materials, it's a constant. It really proves that these foundational components matter absolutely everywhere.
Okay, so let's try and bring this fascinating conversation together, maybe summarize the key takeaways. The core message from everything we've looked at seems unequivocally clear. The impregnating resins market is on a really steady, significant global growth path. It's not just some fleeting trend, it feels like a fundamental part of our industrial future.
Absolutely. If we distill that regional analysis,
Yeah.
Asia-Pacific, driving the fastest momentum, fueled by rapid expansion in advanced industry and tech, especially China and India, innovating at lightning speed. Europe and North America. More mature, yes, but delivering stable, crucial demand for maintaining, upgrading, and greening sophisticated infrastructure. And looking forward, South America, the Middle East, Africa, they represent really exciting emerging opportunities, reflecting their own development paths and growing links to the global tech scene.
And this really brings us back full circle, doesn't it, to the crucial role these materials play. So what did this all mean for you, listening? It means that the increasing use of these resins across sectors like electrical installation, automotive, wind power industry, it underlines a vital truth. These resins are set to remain absolutely essential for efficiency, for reliability, for performance in, well, next-generation applications all around the world. They are literally being built into the bedrock of our technological future. Wow, what a deep dive into a topic that, yeah, on the surface seems maybe super niche, but it's actually this quiet yet incredibly powerful engine behind so much of our tech progress, our daily comfort. It really is amazing what goes on behind the scenes, just powering everything.
Indeed. And maybe this leaves us with an important question to think about. Our growing reliance on advanced tech, it isn't just about the flashy devices, right? It means this growing fundamental dependence on these often invisible foundational materials. So what might happen if innovation in these core materials like impregnating resins were to slow down? Or conversely, what entirely new breakthroughs could they unlock if we keep pushing their limits? It just encourages us to think about those hidden layers of complexity, of innovation, that quietly keep our modern world running.
That's a truly thought-provoking point to end on. Thank you for joining us on this deep dive into the fascinating, if maybe often overlooked, world of impregnating resins. We encourage you to keep noticing the hidden innovations that power our world, because often the biggest impact comes from these essential, sometimes unseen components.